All right, so we're going to look at some more stuff here. When determining actual zeros from a possible list of zeros, there's two methods we can use. We can evaluate each f of p over q to see if it equals 0, and therefore it's a factor or a 0. Or we can do synthetic division by each p over q, and if we have a remainder of 0, then it's going to be a factor or 0. So what we can do is we can plug in, f of the p over q, and if that equals 0, then it's a factor. Or we can take and divide by that p over q, and if we get over here, the very last one is a 0, then it's a factor. Now, if we get anything else, it's not a factor, and so then we throw it out and we go to the next one. We evaluate the next p over q, and if it's equal to 0, then it's a factor. But if it's not, then we throw it out. Or if we divide by the next one here and it's not equal to 0, we throw it out until we find it. And so we keep going down our list until we find all of our zeros. So those are the two kind of methods we can think about here. So let's do our first test. And this one is kind of the easy one to kind of get us started and looking at it, because we're going to have very few p over q's here. So remember, we go 3, 2, 1, 0. So we have all of them. So we're going to look at p over q. We want all plus or minus. And remember, that's a0. This is an. And so guess what? We just have a 1 and a 1. So it's going to be plus or minus 1 over 1, or basically just plus or minus 1. So those are the only two factors we can test. Now, those we don't know if they are or not, but we're going to see if they're actually zeros. And so what I'm going to do is I'm going to do synthetic division, okay? And so we have a 1, a -5, a 2, and a 1. So I'll bring that down. That's 1. 1 times 1 is 1. That's going to be -4. So that's a -4. Plus that's going to be -2. That's going to give me a -2. That's going to give me a -1. Nope, that's not a factor. Okay. Well, let's see about this one. All right. So we have 1, a -5, a 2, a 1. All right, bring down 1. That's going to be a -1. That's -6. That's going to be a 6. That's going to be an 8. It's going to be a -8. It's going to be a -7. Huh, that one's not 0 either. So what we have here is, if we don't find any of them being zeros, we can just say no real zeros, and that would be our answer. Now, usually what happens is we get, some real zeros, and we'll get, maybe one of these actually worked or something, so we would have got a 0 here, and then that would have been a factor. But in this case, luckily, we only had to test 2 of them, and neither one of them are real zeros. Okay. Now, a lot of times you're going to have, like, 10 or 12 things we have to test, and so then it's kind of one of those luck of the draw. Did you pick the right one to test first or not? All right. Okay, what happens if we have complex zeros of a polynomial function? Okay, well, these are going to be like your imaginary numbers, because, we just saw there's no real ones, so maybe there's some imaginaries. So the fundamental theorem of algebra: if f of x is a polynomial of degree greater than 0, then f of x has at least one complex zero. Now, if a is a non-zero real number, then f of x has exactly n linear factors. So we think about that as f of x equals a times x minus c1 times x minus c2 times dot 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 times x minus cn. Okay, where all these c's are complex numbers. So therefore, f of x has n roots if we allow for multiplicities. So that happens sometimes. Maybe we have x minus c1 to the fourth power. Okay, so sometimes we have, multiplicities of, in this case, 4. So complex numbers can be real and or imaginary. So here we have a complex conjugate theorem. If a polynomial with real coefficients has a complex 0 in the form a plus bi, then the complex conjugate a minus bi is also a 0. So if we find one of them, then we also have the other one by just default, because we have to have the complex conjugate as well. And that's basically necessary to get rid of any imaginary term, because if you think about it, if we take that a plus bi times our a minus bi, what happens? Well, we get a squared, and then we take a times bi, a negative bi, so we get a negative a bi, then we take it times here, and that's a plus a bi, and then this is going to be a minus b squared I squared. And remember, I squared is equal to a -1. Okay, so when we do this, those go away. We have a squared, and it's going to be plus b squared. So we get rid of that I altogether, and that's why it's necessary to have that complex conjugate. All right. So if a polynomial is written in descending order, which is how we always really want to write it, it's easy to determine the possible number of positive and negative real zeros. And this is by Descartes' rule of signs. So if we let f of x equal, our normal polynomial written with n's and n minus ones and so on, and it's a polynomial with real coefficients, the number of positive real zeros is either equal to the number of sign changes of f of x or less than the number of sign changes by an even integer. Okay. So, if the n is whatever, if we have a positive number of sign changes, um, and it's uh, uh, I'm not even gonna make an example because I'll mess it up here. But that's how that one works. Now, if the number of negative real numbers is either equal to the number of sign changes of f negative x or less than a number of sign changes by an even integer. Okay, so those are kind of two things we need to think about. Okay, so on this one, maybe we could have a 4 or a 2 or a 0, and that's for evens. Now, maybe for odds, we have 3 or 1. So it's going down by that even integer. So if we start at 4, it can be 4, 2, or 0. If we start at 3, it can be 3 or 1. Okay, we can't be a negative 1, and then just 3 or 1. Okay. All right, so what we need to do now is we need to find all complex zeros, real and imaginary. So this is kind of pulling everything in that we've done up to this point. So what we want to do is we want to look here and remember, we're going to do this kind of and look at it. So as f of x, we're going to look and see how many sign changes there are. And then we're also going to look at f of negative x and see the sign changes. And so what we have here, let's do f of negative x here. F of negative x is going to be, well, if we plug in a negative x here, we'll get a negative x to the third. Plug in negative x here, that's going to be plus x squared. Plug in negative x, it's negative x plus 1 equals 0. Well, it equals that, so we don't really want the 0 there. We plugged it in. And so now what we're going to do is we're going to say, okay, well, there's a sign change. There's a sign change, and there's a sign change. So we're going to either have 3 or 1 real negative zeros. Okay. And now, so what we need to do now is think about positive real numbers. So number of positive real zeros is equal to the number of sign changes of f of x, or is less than the number of sign changes by even a number. Well, how many sign changes do we have? None. 0. So that means there's going to be 0 positive real numbers. IVE real numbers. Okay. So that was the f of x. This is the f of negative x. So now we know those two things. And so now what is our p over q? That's our next thing we need to look at. Well, that's going to be, again, our a0 over an. Well, here we have 1 and 1 again, so it's going to be plus or minus 1, basically. Okay. So again, we're just going to do our synthetic division, and I'll start with negative 1 just because. So we have 1, 1, 1, 1. 1, 1, 1, 1. Bring down our 1. That's going to be a negative 1. That's 0. That's going to be 0. That's going to be 1. That's going to be negative 1. That's going to be 0. Aha, that's good. So that one tells us that is going to be a factor. Okay, and then if that's a factor, what's left over here? Well, that's x squared, that's x, and that's just our number. And so we have then x squared plus 1 is what's left over after we do that division. Okay, now what we need to do now is think about this one. Can we factor it? Well, what happens is if we take x squared is equal to, well, x squared plus 1 is equal to 0 because we have it set equal to 0. If we subtract 1 from both sides, we get x squared equals negative 1. Take the square root plus or minus. And so x is equal to plus or minus the square root of negative 1. Well, what is the square root of negative 1? So way back when we saw that that was equal to I. And again, it's going to be plus or minus I. Okay. So our factors are going to be, we tried the 1. If we tried 1, it actually won't work. So we'll try it, but it's not going to work. We found the -1, it worked, but if we try the 1, if we had gone with that instead, and this is kind of just to show you what happens if we had done that instead. I just picked -1 because I like to do negative numbers sometimes. So 1 times 1 is 1. That's going to be 2. That's going to be 2. That's going to be 3. That's going to be 3. That's going to be 4. That's not a factor. Okay, so that one is not a factor. We tried that one first. It was a factor. And then we got to this point and we saw that, we usually can't factor that. If we had x squared minus 1, that could be factored, but we got x squared plus 1. So that gave us these imaginary numbers. And so our list of all complex zeros is going to be x equals 1, x equals -I, and x equals I. Okay. Now this one we got by definition because we also knew that they had to be conjugates to work. And so we had I times a -I, so it's going to be I squared, -I squared is going to be 1. And so those are going to be our 3 complex zeros. And we had to have 3 because we have the power of 3 here. Okay. So this is just the regular 0, and these are our conjugate imaginary zeros. Okay. All right, so that's how we do that one. And again, I just got lucky, picked the -1 first. If I could chose the 1, I would have found it wasn't. Then I had to go to -1 and got to it. And once I got to it, I noticed that this here is not factorable by any means that we know. And so then we had to go, and that's where we got our imaginary number at. All right, so this one looks a little bit bigger. We have, it's going to have 4 possible zeros. Now, if we look at the sign changes, we have 1. So there's going to be 1 positive real. Now, if we do f of -x, what happens? Well, that's going to be x to the 4th minus 2x third plus 22x squared minus 50x minus 75. So we're going to have 1, 2, 3, and that one's not going to be 1 because it's stat. So we'll have 3 or 1 negative reals. Okay. All right. So those are our possibilities: 1 positive and 3 or 1 negative. Now, what is our p and our q? Plus or minus p over q. Well, q, luckily, again, is 1. So it's always going to be divided by 1. So no matter what we do, now we just have to find our possible factors of 75. All right, so 75. Well, that's going to be, well, we know it's going to be a 5 and 15, and that's going to be a 3 and a 5. But we could also do something else here. We could take and say, okay, well, let's break that into 25 times 3, because if we could divide that by 3, we get 25. And of course, we still have just the 1 and 75. So we kind of have to think about all the possible weird values we can multiply together to get our 75. So we could take 1 and 75, 3 and 25, and then 3 times 5 and 15. We're going to have a lot of things. So what we have is now plus or minus, well, we have a 1, plus or minus, well, we have a 3, plus or minus, well, there's a 5, plus or minus, well, we've got a 15, plus or minus, well, we've got a 25 as the next bigger one, plus or minus, and then the last one would be just 75. So that gives us 2, 4, 6, 8, 10, 12 possible values to actually test here. Now, I'm wondering if I left a blank page, good. So we got to test all of those unless we find, using the theorem, if they're all positives or negatives, that's going to be an upper bound, or if they're alternating, then that's going to be our lower bound. So those, if we see those, that's going to be a really a good thing. All right, so I don't know what the best way to do this is. Maybe let's try to find our upper bound first, and then maybe after that we can go towards the lower bound. So we'll start with the positives, work our way through, and then we'll go down and get to our negatives and see if there's anything there. Okay. All right, so let's try +1. So when we do that, what do we get? Well, we have a 1, -2, 22, -50, -75. All right, so bring down our 1. 1 times 1 is 1. Subtract, that's -1. That's a -1. That's going to give us 21. That's going to give us 21. And now when we subtract that, that's going to be, let's see, make sure I'm doing this right one. Oh, I'm using the wrong numbers here. I just noticed that. I'm supposed to use those numbers, and I was plugging in off the f of -x. So sorry. Let's change those. Those are not going to be right. And so those aren't going to be right. Oops. All right, so now we have the 1, the 2, 22, 50, -75. Now we can work. 1 times 1 is 1. 2 and 1 is 3. 1 and 3 is 3. That's going to give us 25. It's going to give us 25. That's going to give us 75. That's going to give us 75. That's going to give us 0. Aha, so we've got one of our values. We've got a 1. And it says we're going to have one positive real. So guess what? It also has all positive numbers. So we have found our upper bound, and it is our positive real. And so what do I want to make a list of these? Maybe I'll put it over here. So x equals 1 is going to be our 0, one of our zeros, okay? And it's the positive real 0, and it's the upper bound. So that means now we start going with the negatives. And so let's start with -1 and see what we get. Now, again, I have to remember to do the top one. 1, 2, 22, 50, -75. All right, so bring that down, that's 1, multiply that's -1, that's going to be a 1, that's going to be a -1, that's going to be 21, it's going to be a -21, and that's going to be 9, that's a 2, and that's going to be a -29. That's not equal to 0, so that's not a factor, okay? All right, so let's go to the next one. And so the next one would be a 3, and it's going to be a negative. And we had, again, 1, 2, 22, 50, and -75, if I remember right. So bring that down, that's 1. That's going to be a -3. That's going to be a -1. That's going to be 3, not a 4, not adding here. A +3. That's going to give us a 25. That's going to give us a -75. That's going to give us a -25. That's going to give us a +75. And that's going to give us a 0. So that's a factor as well, -3. And if you notice, we went plus, minus, and we call that a plus, okay? So that's going to be our kind of our next one here. All right. Now, did I do something wrong here? Didn't do it exactly wrong. That is a factor. But I just realized something. That doesn't tell me anything. What I should have used is this. Because I already knew after I factor out that 1, that gives me a smaller thing. And so I know that x equals -3 is a factor, but I need to use 1, 3, 25, and 75. All right, so I'll do this whole thing again. And this is something you're going to end up doing too, I can guarantee. And 1, 3, 25, and 75. All right, so now we're going to see if it's a factor of this. All right, so that's a 1. That's a -3. That's a 0. That's a 0. That's a 25. That's a -75. And that's a 0. So it still shows it's a factor, but we've reduced it down because this one, we went from an x to the 4th, and we got 2 here. We got 2x cubed, x squared, x, and 3, 2, 1, and then just the number, okay? Well, that helps us because then, if we went from that, then that would be x2, x, and then a number. But what we did is we went back to our original one. And so that's going to be x3, x2, x1, and then a number. So that doesn't really help us because we're still back to the cubic. And this one, if we had gone this way, here we're back to quadratic. Okay, so what does this quadratic give us? Well, it gives us x squared plus 25 equals 0. All right, so guess what? Now we can say, okay, well, that's x squared equals negative 25. We can take the square root of both sides. We'll take the plus or minus of that one. And so that's going to give us x equals. And now the square root of 25 is 5, but the square root of that negative 1 is going to be an I. And so that gives us plus or minus 5i. And again, so one of them is 5i, and we need the conjugate, which is the negative 5i. So these are conjugates. And so those are two imaginary values. So then we have up here x equals 5i and x equals a minus 5i. And so we've got our four factors, which is what we needed. We have one positive real, which is this one. We ended up with one negative real, which is this one. And then we have the two imaginary. Okay. All right. So again, you have to kind of really remember what you're doing here and pay attention. And if I would have planned this better, I could have said I did that on purpose, but I didn't. I did it on accident. I just wasn't paying attention. I should have used those values when I started dividing. And actually, I should have done it here. And when I did the division, it still wouldn't have worked. But when I did it here, it would have got me to this point here instead of here, which one I had to factor some more. So you got to pay attention kind of in what you're doing. Otherwise, you're going to end up doing extra work that you don't really need to do. All right. So let's stop there and we'll come back with some more.